Hello and welcome back to JD Science Prep. Today we are discussing naming branch chain alkanes. So in past videos we have talked about straight chain alkanes. Today we will be talking about those branches or substituents. Okay, so it says that branch chain alkanes are those with alkyl groups attached to the parent chain, and alkyl groups occur when a hydrogen atom is replaced on a parent chain. So let's take a quick look here at what a alkyl group actually looks like. So on this hydrocarbon that I'm just circling here, we have a scenario where a hydrogen atom is replaced with, in this case, a CH3 group. Okay, so this little circle right here represents a CH3 group. So instead of that hydrogen atom to just make this hexane, we now have to take this branch or substituent into account when naming this hydrocarbon. Okay, so alkyl groups are named similarly to straight chain alkanes, except the suffix of ane is replaced with the suffix of -il. Okay, so if we take a look at this example right here, we're just going to name our substituent. Okay, so if we take a look at what I'm circling here, we see that there are two carbons attached to the parent chain here. So we have a CH2 group. We also have that CH3 group on the very end. And if you think about naming straight chain alkanes, you'll remember that if we have something that looks like this, so we have a carbon-carbon single bond and each carbon is attached to 3 hydrogen, this is called ethane. So according to the rule above, when we have something that looks like this with a CH2 group and a CH3 group, this is going to be called a ethyl group. Okay, so that suffix of ane is just replaced with -il. Okay, so remember or make sure you are refreshed on the prefixes for naming alkanes, because that will come in handy when naming these substituents. Okay, so we have a few rules that we can take a look at for naming branch chain alkanes. Rule number 1, it says name the alkane based on the longest parent chain. Number 2, it says number the carbon atoms on the parent chain so that the carbon atom with the substituent or branch has the lowest possible number, and hyphens are used to separate numbers from words, and commas are used to separate numbers from other numbers. And finally, if there are more than one, or if there's more than one substituent or branch, write the names of the substituents in alphabetical order and do not take prefixes into account. So let's make a little bit of sense of this. But first, we're going to take a look at the naming structure here. So we have an example here, and in this case, it looks like we have a parent chain that has 8 carbons, and we have a substituent that has 2. So notice that our substituent is on carbon number 4 here. Okay, so how we're going to name this is we're going to start off with the number of the carbon that the substituent is attached to, and because this is we have a CH2 group and a CH3 group here, it is going to be a ethyl group. And finally, we have carbons 1 through 8 on the parent chain. I'm just going to circle the parent chain here. This is the longest possible chain in this hydrocarbon. And because it has 8, it is going to be octane. Okay, so notice our number here, our number 4, and our alkyl group is separated by a dash here. And finally, since we don't have any numbers between our alkyl group and our parent chain, we do not have to separate this whatsoever. There's nothing between the ethyl and the octane. Okay, so this hydrocarbon is called 4-ethyl octane. All right. Okay, let's get into a couple or a few more examples here. So number one, let's take a look first off at what the longest possible parent chain is. So I'm going to circle something here. And although this is in a straight line, this is not the longest possible parent chain. Okay, so one thing to take into account is that the parent chain does not have to be in a straight line. Okay, so in this case we have the longest parent chain as heptane, and you will notice, I'm just going to bring up a different color here. I'll use blue. Not part of the parent chain, we just have a methyl group. Okay, so let's number our carbons here, and making sure that the carbon that the substituent is attached to is on the lowest possible number. Okay, so if I bring up, let's use red here, I'll try numbering it this way. So we have 1, 2, 3, 4, 5, 6, and carbon 7 down here. Okay, so in this case, our methyl group is attached to carbon number 4. And I am going to try to number the carbons the opposite way. So we have 1, 2, 3, 4, 5, 6, and 7. And you will notice that it makes no difference whatsoever. Our substituent or our methyl group is attached to carbon number 4, no matter the way we number the carbons. So we can start off with writing, I'll switch colors back again here. So our substituent is attached to the 4th carbon, and it is called a methyl group. So we have 4 methyl, and our longest parent chain is heptane. So we have 4-methyl. 4-methyl heptane is the name of this hydrocarbon. Okay, let's move on to example number 2 here. This is a line structure, so it's drawn a little bit differently, but it means the same thing. So we'll start off the same way we did before. We're going to number our carbons. So first I'll start left to right. We have 1, 2, 3, 4, 5, and 6. So for sure we know that the parent chain is going to be hexane, okay? But in this order, we have our substituent attached to carbon number 4. Let's try it the opposite way now. So we'll go right to left. So we have 1, 2, 3, 4, 5, and 6. So here our substituent is attached to carbon number 3. So that is the way we must name this hydrocarbon. Okay, so we have 3, and again, this is just a methyl group. Okay, we only have a CH3 group attached to carbon number 3, so we have 3 methyl, and like we said before, the parent chain is hexane. Okay, so we have 3-methyl hexane. All right, let's move on to example number 3. This is a little bit more intimidating here, but I think we can accomplish this. So again, we're going to start off by numbering our carbons. So first I'm going to try left to right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our longest parent chain is going to be decane. I am going to write that down actually, so we have that for later. And we have to try the other way now. So let me just bring up my eraser really quickly. So we're going to try numbering it right to left now. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And our first substituent is on carbon number 3, so it makes sense to use this order of numbering. Okay, so I'm going to circle our substituents here. I'll pick a different color. We have a methyl group here. We have a ethyl group on carbon number 4, and on number 7 we have another methyl group. Okay, so we must take these into account while naming this. And remember from our rules above, we must put these alkyl groups into alphabetical order. So we have both methyl and ethyl groups. So according to alphabetical order, the ethyl group should come first. So we can start off by saying 4-ethyl. And we must name our methyl groups now. So we have 3, 7. And because there are 2 methyl groups, we have to use the prefix of di before methyl to depict that there are 2 methyl groups. So far we have 4-ethyl, 3,7 dimethyl, and our parent chain, we almost forgot about that up top. We have decane. So this accounts for our parent chain and our substituents. All right, that is it for this video. I hope it has helped. If it has, like and subscribe. Thank you very much.